Okay, so today I'm going to talk about resistances in series. So resistances in series are actually very simple. And let me just say series. Let me just draw a very simple circuit. So let's suppose that I have a voltage source like this. And then I have a resistance here, and a resistance here, and a resistance here, and then all the way down back to the power source. So the power source is going to be 12 volt. I'm going to call this V. This one is going to be my resistance 1. It's going to be 1 ohm. This one is going to be my resistance 2. It's going to be 2 ohm. And this one is going to be my resistance 3. It's going to be 3 ohm. So the thing here to keep in mind is this. When you have three resistances in series, each one shares an end with the other, and the end side of one is the input side of the other. So this takes something in input, gets something in output. The output of this one is going to be taken as an input by this one, which is going to output something here, and the output on this of this one is going to be taken as an input by this one, and it's going to be an output here by this one, and then all the way back to the power source. So we said that the current is going to flow this way and this way and this way, all the way back to the power source, like the battery. Now, when we have something like this, we can say that this is actually equivalent to writing a single circuit with an R total, so with a single resistance. So I can say, okay, this is exactly like saying that I have a 12 volt battery and a single resistance, which I'm going to call R total. So this resistance here, R total, is going to be given by the sum of those resistances. So it's basically like saying, okay, fair enough, I'm just gonna have one big fat resistance here, which is gonna be given by the sum of all those three, instead of having three resistances. So if I had to do that, I would say, okay, the total resistance will be given by R1 plus R2 plus R3. So R total will actually be 1 plus 2 plus 3. So R total is, well, 3 plus 2 plus 1 is 6 ohm. Now, if I want to find the total current, for instance, I can say, okay, Ohm's law. So remember V, I, R. Remember the triangle? So I want to find I is V over R. So I is just 12 volt over R total. Well, I should really be writing R total. So over R to over, I screwed up. So it's 12 over 6. So I is just 2 ampere. Now, whenever I write series, I generally write equal current, different voltage. And it is something very, very important. Remember this. Before thinking about, oh yeah, but they're like this, think whenever I say series, think about same current, different voltage. What this means is that when I have a circuit with three resistances in series, which is like saying that they are like this, which is like basically saying that they are like this, so one next to the other. So when they are in series, they all share the same current, but the voltage is different. And we can see that we have just found a current, which is 2 amps. So 2 amps is going to be across all those three. So here it's going to be 2 amps, 2 amps, 2 amps. Now, if this is true, then I can basically demonstrate that the voltage is going to be different. And this is actually pretty obvious because we have a battery here, which is 12 volts. And we're going to have a voltage drop across this resistance here, and a voltage drop across this resistance here, and another voltage drop across this resistance here. So I can actually say that the voltage here is going to be 0. And from here, the battery is going to push it up to 12 volts. So we know that there is 0 and here is 12 volts. So now, what's the voltage here? Well, let's see what the voltage drop is going to be. We're going to have a voltmeter here. So basically, what's a voltmeter? Well, a voltmeter is just something to measure voltage. So if I want to measure the voltage drop here, I can say, okay, I'm going to call this VR1, so the voltage drop made by R1. So if you remember the voltage, I want to find the voltage, so it is I times R, still because of Ohm's first law. So I times R, well, of course, R1. So VR1 is 2 amps times R1, so times 1. So VR1 is just 2 volt. Now, so the voltage drop across here is 2 volt. Now let's see the voltage drop across this one. So if I gonna put a voltmeter here, so VR2, the voltage drop here is going to be I times R2. So VR2 will be 2, which is the current, times this resistance, 2 ohms. So VR2 is 4 volts. Now, let's do the same thing for this other resistance. Now the voltage drop across this third resistance still gonna be given by I times R2. So VR3, I'm sorry, I times R3, VR3. So VR3 is 2 amps times the value of R3, so times 3. So VR3 is 6 volts. So now I can say that V is VR1 plus VR2 plus VR3. So VR1 plus VR2 plus VR3. So V is actually 2 plus 4 plus 6. I can see that 6 plus 4 is 10 plus 2 is 12 volt. Exactly what we imagined. We have got the initial voltage back, which means that it's fine. So everything is fine. Now, the voltage has been, going down here and here and here till it got to 0. And this is basically one of the reasons why I said that in series, we're going to have the same current and a different voltage. So those three are going to share the same current, but are going to have a different voltage.